Eta Carinae is the most massive star within 10,000 light-years. In the mid-19th century, a tremendous eruption hurled enough gas into space to make at least 10 copies of the Sun, creating an expanding nebula still visible today. New results from NASA satellites, ground-based telescopes, and theoretical models are providing astronomers with an improved understanding of the system. At the nebula's heart lie two giant stars. The smaller of the two is 30 times the mass of the Sun and 1,000,000 times brighter. The primary weighs 90 suns and shines 5 times brighter than its companion. Both stars produce powerful outflows called stellar winds, but the primary's is so dense it prevents astronomers from directly observing the star. The secondary's orbit is among the most eccentric known. Every 5.5 years, when the two stars swing toward closest approach, or periastron, they come about as close to each other as Mars is from the Sun. Eta Carinae's most recent periastron occurred in August 2014, and many of NASA's space-based telescopes, as well as ground-based observatories, looked on. Where the stellar winds collide, temperatures reach hundreds of millions of degrees, hot enough to emit X-rays. But the X-ray emission shuts down near periastron when the smaller star is swallowed up by the dense wind of its larger companion. The X-rays gradually recover after periastron, but they do so a bit differently each time, suggesting structural changes in the dueling winds. Recent observations have helped theorists refine computer models of this interaction. Here, darker colors indicate lower gas densities around the stars, while the stars themselves appear as black circles. When the stars are far apart, the winds collide head-on, creating a huge cavity surrounded by 50 million degree gas. But near periastron, the secondary whips around the larger star, carving a tunnel through the primary's dense wind. The secondary star's rapid motion changes the collision zone from head to tail. The smaller star's faster wind flows out along the cavity it created and then crashes into the outward-moving wind of its companion. From our perspective on Earth, the X-rays fade, then recover as the stars move apart. New 3D models of these simulations reveal the formation of finger-like protrusions along the cavity near periastron, features never before identified. Theorists now investigating the phenomenon suggest they may arise from instabilities developing in gas as it flows along the cavity wall. Astronomers also keep an eye on Eta Carinae with the Hubble Space Telescope. These images show a structure resembling a crab, formed by gas excited by the secondary star's intense UV light. This light dims near periastron when the secondary passes through the thickest part of the primary's wind. The gas relaxes, settling into a lower energy state. As a result, the crab appears in a different spectral line until the stars move apart and the UV light is restored. Eta Carinae is one of the closest and most massive colliding wind binaries, and serves as a natural laboratory for studying these rare and important objects. While its past eruptions remain unexplained, astronomers think they have a handle on its current state, a claim to be tested at the next periastron in February 2020.